Okay, guys, so we're going to start recording here. So, our goal today is that we are going to talk about our polyatomic ions and also start with being able to name and identify the formula of our basic, simple binary compounds. Ionic compounds. Binary just stands for two. That's all we're doing. Oh, can't see that too. Now, you may see, so what we're doing here is our LIQ for today is how do we name and write formulas of ionic compounds. Now, it does say what is not completed today is going to be wrapped up for homework for next time. That's not the case. We are going to finish at least pages 1 and 2. Pages 3 and 4 will be completed after the unit test. That is our goal for today. We're going to make some note cards for the ionic compounds, ionic polyatomic ions that we have in front of us. There's 16 of them. And we're going to talk about naming our binary, our simple ionic compounds. Now, here's the thing. Now, unfortunately, you can't see my image because it is kind of scrunched up, and we're looking at a picture through not a great camera. There are 16 of these guys in total. Now, here's the thing, is that I would not offer a testing strategy without giving you guys the tools to use that testing strategy. Now, as most of you guys can clearly see, Mr. Wiseman is a teacher, and I don't know if you know about teachers, but we're severely underpaid. So that means I got to be out here balling on the budget, so we got to make tools work, tools stretch. We're going to make flashcards today of our polyatomic ions. There's 16 in total, and you should have 4 flashcards. Everyone got 4 flashcards? Perfect. What you're going to do, we'll just toss it right here. What you are going to do is that we're going to choose one side of our flashcards to be our name side, and one side to be our ion side. What we're going to do is we're going to cut our flashcards up in a second. You're going to choose one side to write the ion, so make sure you're writing the formula and the charge. It's very important that you know both on one side and the name is on the other side. Now, how am I going to make four cards stretching to 16? Simple. I take one flashcard. Want everyone to go ahead and give me a quick, want you to fold it there in the middle for me? Kind of like a hot dog or a taco, whichever one you feel more comfortable with. Get a nice big crease in it. And then what we're going to do is we're going to do something crazy. We're going to do the exact same thing. We're going to fold it one more time. Same way, taco or hot dog style, whichever one you feel comfortable doing. Because from one card, I will make 4 cards. In the middle of your row, or somewhere along your row, there should be a beaker with some scissors and a hole punch or 2. Now, it's important that we realize that we don't have enough scissors to go around to everybody, and we clearly don't have enough hole punchers for everyone to use on their own. So that means that we are going to be big boys and big girls and big people and share. What you're going to do is you're going to take your scissors and you're going to cut along those creases. So if I go ahead and cut the one here in the middle. Boop, 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 boop. There we go. I cut along the middle crease as well. And voila, Mr. Wiseman has done magic as he has made 1 card become 4 cards. Oohs and ahs across the table. Now, here's the thing. What you're going to do is after you cut your 4 cards to make your 16 cards, you're going to choose one side to be the name side and one side to be the ion charge side. Doesn't matter which one you choose as long as you are consistent with it. One side's one side's the other. Now, do I expect you to paperclip all these things and magically when you stick them in your pocket or in your backpack later today, they're all going to be there exactly the same way, same order? Absolutely not. So we're going to do a little trick to fix that. That's where the hole punch comes in play. So you don't have to do these individually. You can put 4 of them together. You can punch. You can use our single hole punch at a time. I would not recommend trying to put all 16 of them through the hole punch. It will not work. These are Amazon products, guys. This is my money. So please don't destroy my hole punches. I kind of need them to stretch a little bit. Take 4 of them. Pick a corner. Be consistent with your corner. And you're just going to simple punch a hole through it. Oohs and ahs heard from all the way in the back. Now, here is where the real magic comes into play. Now, this is where we're going to be super duper magical. And I'm going to grab the camera here so we can see it. Now, as we know, paper clips, they have the larger loop and the inner loop, the smaller loop. Guys, take a look at the screen real fast for me. I want you to take your paper clip and I want you to stretch it out to a forms of V. Very similar like this. We have the smaller loop, we have the larger loop, right? One loop is bigger than the other, yes? You want to take the smaller loop. And you may want to bend it in just a little bit to make it fit a little bit easier. You're going to push the small loop through the hole. And then bend it back. And now you've created a little ring binder for all of your cards. That's why it's important that we pick one side to be the name side, one side to be the Ion side. You are making your flashcards. Simple, easy. I will tell you this, is that as you saw on the GIST slide, the Get Your Shit Together slide, you will not have a quiz on the polyatomic ions next time. It will be Tuesday. I'm going to be absolutely frank with you. I'm going to give you 11 of these polyatomic ions, and you're going to have to match those 11 polyatomic ions to their formula. 16 you have to memorize, or else the rest of your time in chemistry is going to be an absolute pain. To give you guys time, I got a little timer up here. I'm going to hit the timer for 10 minutes. Once it pops up, come on, populate, you sucker. There we go. I'm going to give you 10 minutes to work on it. After that 10 minutes, I got to move on. We're a bit pressed for time. We're a little bit behind the other chemistry classes. That's why I'm focusing so hard today. So, 10 minutes. Share with each other. Excuse me. And you'll be fine. Oh, this month, I might have to change my... There we go. Everybody good with the flashcards? We got the colors that we wanted, or everything lined up? All right. Hey, one more person. Good. is what it is, man. Ain't no sense of All right, guys, about halfway through our time.
Yeah.
Gentlemen, we don't know punch. That's it. Thank you, Jim.
Yeah.
It's shaking. It's been abused. All right, ladies and gentlemen, in 45 seconds, we're going to move forward, whether you're ready or not. I gave you the tools. I just need you to use the tools in the meantime. So like I said, I'm expecting that Friday is also going to be another 2-hour delay for us. We're going to spend 35 minutes taking the test, the abbreviated test, and then we're going to use the rest of the time to finish up what we're starting today if we don't get done with it. Good chance we may get done with it. We'll see what happens. Yo! Done. Your cards. I'm not grading y'all whether you get a whole bunch of the right side of the card or not. I'm just giving you the tools that you could use to help you prepare. All right. So like I said, I am moving forward, and you are going to want to write this down. So here's the thing, is that though you have the 16 that you are required to memorize, put to your head, these are the most common polyatomic ions. Poly just means that we have multiple elements together that form one ion. There are 3 that I would like for you to write down on your polyatomic ion sheet. At the bottom, so here's my polyatomic sheet, right? At the bottom of that sheet, you want to write down these 3 other polyatomic ions. Chromate, permanganate, and peroxide. Now, like I said, these 3 you don't have to memorize. But we are going to see them often. We're going to see them fairly often, again and again. From this unit, excuse me. Let me zoom in on a little bit. I can zoom in on this side. There's my zoom. Let me see a little better. There we go. We can see a little bit better in the back now. These polyatomic ions are going to keep coming up. They're a big thing here in our nomenclature unit. They're a big thing when we get into balancing equations, Unit 7. They're a big thing when we get to stoichiometry, Unit 8. It'll be a big thing when we get to Unit 10. It's very important that we understand that we memorize those 16 polyatomic ions and we are aware of these 3. Chromate, permanganate, and peroxide. Okay. Well, you were going to those three goes right down here. You're not expecting to memorize those. Mm-hmm. Yeah, these three I don't expect you to memorize, but I want you to be aware of them because we're going to keep seeing them. That's all this is. Now you may have noticed a lot of your ions are very similar. Like nitrate. There's nitrate, there's nitrite. There was chlorate, there was chlorite. And there was hypochlorite. I believe I remember correctly. Is hypochlorite one of the ones you have to remember? Hypochlorite one of the ones you have to memorize? I believe it is. I could be wrong. Where's my sheet at? Here we go. Yeah. Hypochlorite, chlorite, chlorate, and perchlorate. Yep. I'm not crazy. But we should have noticed that there's a bit of a pattern. Now I know 16 elements is going to be hard to memorize, but we do have a little theme to help us out. Now, online I do have these slides available to you, and this link does work. It shows you the exact same link that we use to identify all of the eights. So I have a small sentence to help us identify all the eights. Nick the camel ate a clam supper in Phoenix. Now we have to ask ourselves a couple questions. One, is Nick a good name for a camel? Number one. Number two, why is a camel eating clams? That's a bit weird. And what the hell is it doing in Phoenix, Arizona? On my way to Tacoma. Oh, maybe one Eagle fan out there. But this sentence is going to help us identify all of the polyatomic ions that end with 8. Those are going to be my nitrates, my carbonates, my chlorates, my sulfates, and my phosphates. That's only 5 of them. But what we're going to see, if I know my 8s, I know all my ites. If I know all my ites, I know all my hypoites. It's all based on how many oxygens are present. So, nitrate, carbonate, chlorate, sulfate, phosphate. The word tells me everything I need to know. The first letter represents the nonmetals attached to. N for nitrogen. N. The number of consonants in Nick represents how many oxygens are present in the polyatomic ion. NCK. So that's 1, 2, 3. 3 oxygens. NO3, only 1 vowel minus 1. The number of vowels represents the negative charge. N starts us off with nitrogen. 1, 2, 3 consonants. NO3. The vowel is I minus 1. Camel. We start off with C, so I start off with carbon. 1, 2, 3 consonants. The C, the M, and the L. CO3. 1, 2. The A, the E are my 2 vowels. CO3 minus 2. That's fine. Clam, Cl, that's my element symbol for chlorine. So Cl, I see 1, 2, 3 consonants. So ClO3, 1A, ClO3 with a minus 1 charge. Supper starts with an S. The chemical S is the chemical symbol for sulfur. 1, 2, 3, 4 consonants. SO4. 1, 2 vowels. SO4 with a charge of minus 2. Phosphate Phoenix starts with a P, which is the same symbol for phosphorus. 1, 2, 3, 4 consonants. PO4. O, E, I, or my vowels. PO4 with a charge of -3. If you're curious of how I got this, I do add the website that you can it's not a hyperlink, but you can copy and paste that into a new window, and you can watch the exact same video doing the exact same thing with you. Sometimes it's always good to hear from another person. That's where you can hear from another person. If you're looking for something to write down, I just write the sentence down. Nick the Camel ate a clam supper in Phoenix. And that's a way to remember all of my 8s. Because you should have already written down nitrate and its ion, carbonate and its ion, chlorate and its ion, sulfate and its ion, phosphate and its ion. Use your time wisely. You don't have to write everything down. Now, like I said, if I know all the 8s, I can identify all my ites. And how I'm going to do that is with the next slide. To get my ites, N-I-T-E, it's 1 less oxygen than my 8s. Great example of this. We'll slide this up just for a quick second. My nitrate is NO3 minus 1. So that's my nitrate. If my nitrite is 1 less oxygen, what is the symbol? What's going to be my ion for my nitrite? If it's 1 less oxygen, what is it? NO, how many oxygens? 2. Minus 1. If I know my 8s, I know every ite. If I know my ites, I know every hypo something ite. Our example of this is chlorate. Let me grab another piece of paper. Another piece of paper that has something around the back. Give me a quick second. There we go. So leave that right there. So if I'm looking at chlorate, ClO3 minus 1, is it right? Yes, minus 1. That's my 8. I know my chlorite is ClO2 minus 1 is my ite. So what's going to be my hypochlorite? If hypochlorite is just one less oxygen than ite, someone tell me what the formula is for that ion. Starts with Cl. What's the next one? O? Just one O or multiple O's? Just one. Minus 1. Hypo something ite is 1 less oxygen than the ite. So if I know the 8, which is ClO3 minus 1, then I know what the ite is. ClO2 minus 1. It's my chlorite. My hypochlorite is 1 less oxygen than my ite. ClO minus 1. Yes. When she comes back, you got it. My per means one more oxygen than the 8. So if I want perchlorate, it's ClO, how many oxygens? 1, 2, 3, or 4? 4. Minus 1. Notice that the entire time, my charges stayed absolutely the same. The only thing that changed was my oxygen number. None of the above alter the charge. The only time I alter the charge is when I'm adding a hydrogen to it. So if I have something like sulfate, sulfate is normally SO4 minus 2. That's my sulfate. If I add a hydrogen to that, HSO4, my hydrogen is going to act as a positive ion, lowering the charge from minus 2 to minus 1. That is hydrogen sulfate. If I know every 8, I know all my ites. If I know every 8, I know all my hypoites. If I know every 8, I know all my perates. Which comes in handy. So I'm looking at my chart. Nitrate, nitrites, sulfate, sulfites, phosphate, phosphite, hypochlorate, chlorite, chlorite, chlorate, perchlorate, carbonate. There's only 4 of them that I have to kind of put to memory by themselves. Ammonium, acetate, because we don't see acetite. Cyanide, and hydroxide. There's only 4 that's weird, that don't fit easily into my rules. So, best thing for you to do is put those 8s, those 5 8s, to memory. As soon as you know that, you know 12 other ones. You only have to fight for the 4 that don't fit easily into the rule. So instead of 16 that you have to memorize independently of each other, you just have to memorize 9. A much easier hill to cross. Sound good? All right. Let's take a jump into what we're doing today. So, in your packet, your general chemistry naming ionic compounds packet, I want to jump straight to page 2. The reason why I want to jump to page 2 is because it looks a lot similar to what we've already done in the past. We're going to start off with writing formulas for type 1 binary compounds. So make sure you're on page 2, because I will tell you this. At the end, you will be turning in this packet into me. Working with me at the same time is going to make your life a lot easier. Class ends at 2:17. You got to keep that in mind. 2:17 today. So if we take a look at the top, we are going to see, excuse me, we're going to be taking an ionic compound name, writing out the cation and the anion, and also its formula. We've done this already. When we did it, instead of giving you the actual compound's name, I said, hey, we have two elements, lithium and oxygen. Identify the cation, the anion, and the formula. The only difference now is I'm giving you the proper ionic compound's name for this binary molecule, this binary compound. Lithium oxide. So let's look at my example first. Lithium oxide. What's the metal? The lithium or the oxide? Lithium is, right? Does the metal form my cation or my anion? Both are charges. Which one's the positive charge? The cation or the anion? What was it? I heard it. The cation. The cation is the positive charge, right? Remember we drew the little kitty cat? Got the positive eyes. Right? So what is the ion for lithium? What's it going to form? What's the cation going to form? So it'll be a +1, a +2, +3, or +4. Take a look at your periodic tables. Everyone's got one in front of them. +1. So we'll put down for A. Now I can look up and down my periodic table till I'm absolutely blue in the face, and I will not find oxide. Because remember, all of my nonmetals are on this side of the ladder. These are all my nonmetals, right? Those that sit on the stairs themselves, those are my semi-metals, my metalloids, my incomplete metals. So we're focusing on this group right here. Oxide, O-X-I-D-E, does it look similar to carbon, nitrogen, oxygen, fluorine, phosphorus, sulfur, chlorine, selenium, bromine, or iodine? What does oxide look close? What do you see oxide? Which element looks similar to oxide? Oxygen. What is the anion for oxygen? -1, -2, -3, -4. -2. Does this look familiar to you guys? I hope so. We've done this already before. Just like up here. So I said before I give you lithium and oxygen. Now I'm giving you the actual name of the compound. Lithium oxide. We're going to get into why it's oxide in a second, but first, we're identifying the trend. So if I was to write the formula for lithium oxide, how would I go about doing that? Do we remember our charges have to cancel each other out? So does 1 - 2 equal 0? What do I need? What do I need? I need another what? I need another lithium, right? So that'll be 2 - 2. Does that equal 0? So my formula is going to be our Li2O. Does that make sense? Push it up a little bit. Is that making sense? Does it look similar to what we've done before in the past? I hope so. Let's take a look at The other example, aluminum chloride. What's my cation going to be? Give me the symbol and give me the charge of the cation here. What's the symbol for aluminum? Al. What's the charge of aluminum? +3. All right. Chloride. What's chloride look like to you? Based off my group here, it looks like chlorine, right? What's the anion of fluorine going to be? -1. What's my formula going to be? Not -3, but you're right. AlCl3. Because I have a +3, so 3 minus 1 gives me +2. It means I need to add some more negative charges. I need to add some more anions. I need 3 chlorines to cancel out that 1 charge that aluminum has. When we did the Ionic quiz, we did fairly well on this part. This isn't going away anytime soon. Oh, actually, I have it on the next page. So let's look at one. Let's look at one together then. We're looking at number 1. It's very top of my page. Beryllium bromide. I'll start this off for us. What is the cation here? What's going to be the charge on beryllium? +2. What's the anion going to be for the bromine? -1. So what's my formula going to be? BeBr2. I have +2 over here. 2 minus 1 equals +1. Not 0. I need more negative to counteract that +2, right? So I need 2 Br minus 1, 2 minus 2 to give me 0. BeBr2. In the name, do I mention that I use 2 bromines? 2 bromine anions? No. Ionic compounds are some of the easiest ones to name because it does not matter how many cations or anions I use. It's always going to be the name of the metal, then the non-metal with the end cut off as "ide." Let's look at number 15 together. Look at you guys. Number 15 is sodium iodide. Number 15, sodium iodide. For A, I'm writing down the chemical symbol and the charge for the ion. For B, I'm writing the formula. So what's the cation in sodium iodide? Na+1. What is the anion in sodium iodide? I-1. What's my formula? NaI. 1 minus 1 equals 0. I don't need any more ions. This should be a bit more familiar with what you've done before in the past. What I'm going to have you guys do is I'm going to give you guys 10 minutes to knock out the other 14. You want to write out the formula, and then you also want to write, you want to write out the ions, and then you also want to write out, excuse me, the formula. 10 minutes. Your time starts now.
that not an airplane? Yeah, it's a.
So think of it this way: is it easier for me to for lifting to lose one or gain 7? Well, remember, our rule is that it always wants to go back to the nearest number gas. So for lithium, there's only 2 instances between 2 number gases, right? Helium and neon. Right. Well, see, so our noble gases are always in a lower energy state. So that's what we always want to get to. It's just that which way is faster? Losing 1 electron or gaining 7 electrons? Yes, sir.
What's a nice diss track? Because those are rivals. You get things they I know, but make sure your voice up on
I'm coming back. I just heard people talking. Wow, I heard people oh, crazy. Write my formula. That's all it is. You're just doing that for all of them. All right. All right, guys, got about 22 seconds, and we're going to kick over, and we're just going to jump to page 1. All right, guys, so let's take a look at page 1 now. So we've had some practice now with writing the formula. And I feel that writing the formula was easier for us than going straight into naming them. That's why now we're jumping back to now page 1. Whenever we have an ionic compound of 2 atoms, that's a simple binary molecule. Binary just means 2. There's only 2 of them there. Excuse me. We're going to find out our simple binary ionic compounds are always written the same way. It's written with the metal first. So written. If I'm naming it, it's always written the metal first, followed by the non-metal. And what we're going to do is we're going to chop the end of the non-metal off and replace it with "-ide". This symbolizes that it's in a compound with each other. So when I look at CaCl2, that's at the very top of my example, I see calcium. Calcium is spelled out completely. And instead of writing chlorine, I chop off the INE and replace it with IDE. So it's now not calcium chlorine, it's calcium chloride. Notice that there are two chloride anions in this relationship. I do not specify in the naming of ionic compounds how many cations or anions I use. This is something that we are going to see when we are looking at covalent compounds, where we're going to add a prefix to identify how many oxygens we added, how many hydrogens we added. Dihydrogen monoxide is just H2O. Aluminum sulfide is Al2S3. If we looked at number 1 together, number 1 is MgS. What does the Mg stand for? Magnesium. Question to you. Is it going to be, what's the S stand for?
Sulfate.
Not sulfate, you're close. Sulfide. Remember, it's not going to be sulfur. I'm going to cut off the end. Sulfide. Someone give me the name for NaBr. What would that be? Sodium's the first one. Bromide. Sodium. Bromide. If we take a look at page 2, we see that N is our nitride. We see O, instead of being oxide, it's oxide. Because oxygen, if I just chopped off the EN, so it'd be oxyide or oxide, we're going to cut off everything O from Y to the N, oxide. What's fluorine going to be? Fluoride. We already did sulfur. What's chlorine going to be? Chloride. Iodine is iodide, and so on and so on. We're always going to just chop off the N and replace it with the IDE. Sir. A second. Let me get everyone started on this first. And then we'll give Maya a chance. We'll see if she got anything written down for me. And if she does, I'll let her go first. All right. So I want to give you guys a couple minutes. I want you guys to take a stab at it. I want you to try to answer the other ones. There is, how many of them were on that first page? There's 20 of them, so it's 18 of them. Take a stab at naming the other 18. That's easy for me. Alright. Oh, that was a 205. You're answering my questions there. I'll send you down. Come on over. Anticipation is a hell of a thing. Okay. Oh. All right. Put that hammer out. All right. Now I want to try to take a look at page number 4. Page number 4. We're jumping around a little bit. We got 7 minutes. I just want to talk about page number 4, get you guys started on it. So with page number 4, we're taking a look at those polyatomic ions. We're doing the exact same thing because a polyatomic ion is just multiple atoms coming together to form one charge. Poly being more than one, atomic for nucleus, ion. So instead of just having instead of nitrogen just being -3, we have something like sulfate, SO4 with an overall -2 charge to it. We're going to take a stab at a couple of these today. Now, I know I just gave you the piece of paper that identifies all the ones that you're responsible for. I'm not expecting you to be already a master at polyatomic ions. In fact, I don't expect you to be a master until I see you on Tuesday, because I expect you guys to be practicing for your test for Friday. But we're going to do it this exact same way as we did on page 2. I'm going to give you guys the name of a compound, such as strontium hydroxide. If I'm looking at my periodic table, I see strontium is number 38. It's in group 2, so that means it's going to give me a +2. So Sr +2. Hydroxide, that's where I bring in my sheet over here. Hydroxide is an oxygen and hydrogen to give me an overall charge of -1. OH -1. Now, I know that I need to have 2 OH groups to cancel out that strontium charge. So I'm going to ask you a question. Do you think I'm going to write it this way? SrOH2 or SR parentheses OH2? Which one do you think is the right way to write strontium hydroxide? 1 or 2? 2. Because if I leave it like this, SrOH2, I'm indicating that I just have 1 strontium ion, 1 oxygen, and 2 hydrogen. Using the parentheses, if I have more than 1 polyatomic ion, tells me I have 1 strontium ion and 2 hydroxide ions. Let's look at... So I have to grab an example. Let's look at number 1 together. Magnesium sulfate. What is the cation for magnesium sulfate? Mg+2. What is the charge on the ion sulfate? Is it -1? -2? Was it? -2. So what's my formula going to be then? Mg, no parentheses, SO4. Remember, I only use the parentheses if I have multiple sulfates. Here I only have 1 magnesium ion, I have 1 sulfate ion. If I look at number 2, calcium nitrate. What is my cation here? Ca+2. nitrate is NO3. What's my charge? -1, -2, -3. -2? -1. How many nitrates do I need to cancel out the charge on calcium? I need 2 of these, right? So Ca parentheses NO3 2. Only use the parentheses when I have multiple polyatomic ions. We're going to work on this a little bit more next time I see you because we're shy on time. We got a minute for the bell rings, so that's where we're stopping for the day.